All right, let's go ahead and solve these quadratic equations algebraically, which means using algebra. Before, we've solved these by using a graph and finding where they cross the x-axis, and we've also solved them on a calculator by, again, seeing where they cross the x-axis. So this is going to be your third way of solving a quadratic equation. And just as a review, a quadratic equation is just something where you see some sort of quadratic in your problem that has an equation symbol. All right, how would we go ahead and solve this? Well, we're going to basically solve it just like a normal equation where we divide by 4 here to isolate our variable of x. But this time when the 4's cancel, I'm left with an x squared is equal to, and 36 divided by 4 is 9. Well, what do you do here? This might be a review from Algebra 1, or maybe you've never seen this before. But we're basically looking for the number that when you square it, you get 9. And you might say to yourself, oh, I think that's 3, right? Well, what did I just do in my head? I just square rooted that. And a square root and an x squared are inverses, and so they cancel out. And so we're just left with x here. And you might say the answer is 3, and you're correct. But could you think of another answer? If you said -3, you are also correct. This works because -3 times -3 is also 9. So you can write your answer like this, or you can write your answer as x equals plus or minus 3. That's what that symbol means right there, plus or minus. All right, let's take a look at b. Now for b, it's not quite as simple as dividing by 3 because we have to get rid of the -8 first. Remember, we always do the opposite order of operations when we're solving. In this case, we're going to add the 8 first. Okay, my -8 and my +8 disappear. I'm going to drop down my 3x squared, and I get 48. Okay, divide by 3. And 48 divided by 3 is 16. So I get x squared is equal to 16. Last step here is going to be to square root both sides, and I get x equals 4, and x equals a -4. Or again, if you'd like to write it in shorthand, you could say x equals plus or minus 4. You can also see, if you go to your calculator, you can find the square root symbol if you're struggling with saying what's the square root of 16. But that's 4 because 4 times 4 is 16. Let's get a little bit harder, okay? Now, you might be tempted to do distributive property here, and that's actually not correct. The reason why is because you have to do parentheses first, and there's nothing there. And then squaring this is actually going to be a FOIL. So it's not as easy as saying let's multiply through. In fact, that is a wrong step. What you're going to do instead is say I want to divide by 4. Because look what's happening here. My 4 cancels with my 4. And I'm just left with an x plus 1 squared is equal to 100. Okay, now in a situation like this, the whole thing is being squared, so I have to square root everything. So what do I get when I square root a squared? Well, they cancel out, they're inverses, so I'm left with just an x plus 1. And this is going to be equal to both 100, and x plus 1 is going to be equal to -10. My bad. A -10. Because the square root of 100 when you're solving an equation is going to be 10 and -10. See what I did there? You've got 2 answers. All right, so we're now going to solve each of these equations by subtracting 1. That disappears, and I'm left with x equals 9. Over here, I'm going to subtract 1. That disappears, and I'm left with x equals a -10 minus 1 is a -11. So just like, not usual, but most of the time, we're getting 2 answers here. The trick is to say, okay, when I square root this 100, I get 10 and -10. All right, let's go ahead and try this next problem. Similar problem here, we're going to divide by -2. This gives me x minus 1 squared equals negative 36. Then I'm going to square root both. And you might be freaking out saying, uh-oh, I've got a negative under the radical. And yeah, that is a little bit of a problem because we're not going to get a real solution, but we are going to get something with an I in it. So my first answer is going to be x minus 1 is equal to something, and then x minus 1 is equal to something. Well, what is the square root of 36? Well, let's just go ahead and let's do this like we did on the other slide here. So this is going to be the square root of negative 1 and the square root of 36. Well, square root of negative 1 is an I, square root of 36 is a 6, so this would be a 6i. And remember, just like here where the square root of 100 got broken up into a positive 10 and a negative 10, we're going to break this up into a positive 6i and a negative 6i. All right, let's continue with this. I'm going to add 1 to both sides. So I get an x equals 6i plus 1. Same thing here, plus 1, plus 1. Here this cancels, and I'm left with x equals negative 6i plus 1. Now what's so cool about doing it this method is that we actually have two, we would call them non-real solutions. So if you were to actually graph this problem, you would see that it never crosses the x-axis. So there are no real solutions to this problem, but there are two non-real solutions, and we have them here. All right, let's try this one. I think these will be our last two, and I know I've done a series of challenging and some easy ones as well, but we'll make sure we spend plenty of time on this. The minus 31 and the plus 31 cancel. I drop down the 4x squared. 49 plus 31. What is that, 80? Oops, I did it wrong on my calculator. 49 plus 31. Yep, should have trusted myself. I get 80. Divide by 4. X squared equals 20. So I'm going to go ahead and square root this. And I get the answer x equals plus or minus the square root of 20. Well, let's go ahead and let's break the square root of 20 down because we know how to do this now. So square root of 20 is going to be the square root of 4 times the square root of 5. Well, square root of 4 is 2, and then root 5. If you want to do this a different method, you would do it as 2 times 10, and that becomes 2 times 2 times 5.
Good morning, Mr.
All right, so since we have this duplicate, this comes out of the square root, and then we keep this. So this would be a 2 coming out, and then keeping that root 5. So those are the two methods to get that. All right, so instead of writing x equals plus or minus root 20, which is correct, it's just not simplified, I want to write this as x equals plus or minus 2 root 5. All right, last one here, folks. We're going to subtract 9 from both sides. We drop down our 3x squared. This cancels. I'm left with a negative 9. Divide by 3. The 3's cancel, and I'm left with an x squared is equal to negative 3. Next thing we're going to do is square root both sides. Okay, so I get an x equals plus or minus. And notice how I've got a negative under the radical. So let's go ahead and break this down again. So you'll have a square root of negative 1 times a square root of 3, which would be an I root 3. And you cannot break down root 3 any more than that. So your final answer, in most simplified form, would be plus or minus I root 3. And again, this would be another problem where your graph would not touch the x-axis. So we could say no real solution, which is true because look, we only have imaginary solutions, but we do have two imaginary solutions because look, we've got imaginary numbers. Thanks for watching, y'all.